Good morning. I am Dr.S.Thirumavalavan from Bharat University. Today, I am going to just have an introduction on the topic of engineering mechanics. Engineering mechanics is the basic concept of the entire engineering field, and this always deals with statics, dynamics, or the body is when it is at rest and when it is in motion. So, in order to have a detailed discussion about all these topics, we shall enter inside this top and then inside the subject engineering mechanics. So today we are going to discuss on the topic of resolution and composition of forces and resultant of several concurrent forces. Is nothing but a body which is in rest, that is statics, or which is in motion, that is kinematics, which is further classified into kinetics and kinetics, that is dynamics, and all these bodies, either it may be in motion or in a static condition, the forces acting on the body. Understand? So the force acting on the body is nothing but maybe when I am driving a vehicle or when I am traveling over the air, propelling a stone towards the sky. So whatever may be, some force is exerted on a body which is at rest. So we are going to calculate the forces which is acting on a particular body at different angles, and whether it is how to convert into a stable condition. That is nothing but when different forces are acting in a particular body, what happens is nothing but, or either it is acting or pulling away from that body, what happens is nothing but the forces will not be in equilibrium because in all the directions some different loads will be acting. So now what we are going to do is, after finding or resolving all the forces, we are going to find the resultant force as designated by R and the angle at which angle it is acting, and these two gives the position in which quadrant or which direction the force should be acting, the resultant force should be acting in such a way that the entire system is at equilibrium. That is our concept of working today. And before entering inside this topic, let us see what is engineering mechanics. It is the application of mathematics, empirical evidence, and scientific, economic, social, and practical knowledge in order to invent, innovate, design, build, maintain, research, and improve structures, machines, tools, systems, components, materials, and processes and organizations. So very shortly, if you want to say, it is the application of the engineering field which encloses or which considers all the fields of mechanical engineering. Now let us see what is mechanics. It is a science which describes and predicts the conditions of a rest of motion of a body under the action of forces. Not only that, even when the body is at static, also deals with the mechanics. So it is an area of science concerned with the behavior of physical bodies when subjected to the forces or displacements and the subsequent effects of the bodies on their environment. Now let us go for the classification about this engineering mechanics. As you know well about that, as I told you, engineering mechanics is being classified into dynamics and statics. So dynamics deals with the body which is in motion, and the statics is the topic which deals with the body at rest. So in both the cases, we are going to deal in this topic. And once again, the dynamics of the body which is in motion is classified into two types. One is kinematics and the kinetics. So let us see one by one what do you mean by dynamics, statics, kinetics, and kinematics. Okay. Now, statics states that it is the branch of engineering mechanics which deals with the forces and their effects while acting upon a body's at rest. For example, there is a football. So until and unless whenever an external force is exerted on that body, the ball remains at rest. So it means that when the force is acting on a body, it reacts or it gives some effect. So as a result, the displacement is taking place. So now it is a branch in which the mechanics which is dealing with these forces and their effects while acting upon a body which is at rest is called as statics. So now let us come to this topic which is called as dynamics. So dynamics, as I told you, it is dynamics nothing but the dynamics is a body which is in motion. Already you know that, and which deals with the forces on the effects while acting upon a body's in motion. For example, a vehicle is on when it is in motion, or an aeroplane is in motion. So during this type of motion, whenever already it is in motion, a body is in motion, then it is subjected to either two types of dynamics which is called as in kinetics or kinematics. Okay, so now which deals with now dynamics is nothing but which deals with the forces and their effects while affecting upon the bodies which is in motion. So these are the two conditions which you are going to detailedly study about this topic on this resolution of forces or equilibrium motion. Okay, now let us see what is kinematics. It is the branch of dynamics which deals with the body in motion without any reference of the forces which are responsible for the motion. That is, for example, if a body is flying with respect to its gravity or without its gravity, whatever, when it is flying, which is in motion, without any reference of the forces which are responsible for the motion, then it is called as kinematics. Kinetics is nothing but it's a branch of dynamics which deals with the bodies in motion due to application of forces. For example, I am just kicking a football. The ball moves from the, already the ball is in motion. Whenever a ball is in the motion, when I am just once again giving some force on it, or a cricket ball, when it is just thrown towards a batsman, already when it is in motion, you are going to hit it to change its direction. So then these type of forces acting will be dealt on this in terms of kinematics, in the title of kinetics. Okay, right. Now let us go to the next one. As I told you, let us discuss with the topic of resolution and composition of forces and resultant of several concurrent forces. Right. So what do you mean by a resolution of composition force or concurrent forces? As I told you, let us consider if a body is at rest, for example. So on that body, if the forces acting on that particular body at different direction or at a certain angle are towards the center of that body, body which is at rest, ultimately we can resolve the loads and we can find the resultant force by resolving it either by algebraic sum, either by sigma horizontally or the summation of the forces towards vertically also. Now let us take an example and then I'll give you an explanation about how to solve a problem on the resolution of forces, and consecutively we will be solving some problems on this topic. Now let us take an example. Now what you're seeing on the screen is x and y direction, which we call it as a first quadrant. Which we call it as a first quadrant. Now, similarly, this one will be a second quadrant about y-axis as well as minus x direction. The second portion will be called as second quadrant. And as you know very well about this once again third quadrant, and the next one is the fourth quadrant. So in all these four quadrants, if any force is acting either vertically or horizontally or inclined to any of its axis at certain angle, theta 1 or theta 2 or theta 3 or theta 3, which any kind of its quadrant, in any quadrant also, with respect to that we are able to resolve a problem to get the resultant of this force. Okay. Now let us see how we are going to just solve this problem. So now I will consider the first quadrant, and I'll take this as in this first quadrant. I'll just consider a force which is acting at an angle theta 1 away from the point O. For example, take this. Let us see the diagram. We can see this diagram. Let us consider the force F1 which is acting at an angle theta 1 and at first quadrant. Okay. So now we can see very easily either the upward direction y-axis will also be taken as positive, and towards the right side direction also will be taken as positive. If you do the same process in your second quadrant, let us take it as F2 at an angle theta 2 acting from point O, away from point O on the second quadrant, then now we can take it as a minus y as well as minus x direction. Sorry, positive plus y as well as minus x direction. So at an angle theta 2. Now, if you go for the third quadrant, let us take one more force here at the third quadrant, F3 at an angle theta 3, and then we will take it as minus x as well as minus y. In between this third quadrant, we are getting the force F3 acting from point O, away from point O. Similarly, in the fourth quadrant also, let us consider one more force acting F4 at an angle theta 4 away from this point O. Now, the question which we have taken it as, nearly some 4 forces are acting in all the quadrants at an angle theta 1, theta 2, theta 3 and theta 4 respectively. Now, immaterial of the load, force, whatever it is acting or whatever may be the angle theta 1, theta 2. So let us take it as it is and let us see how to resolve this to find out the resultant force theta as well as r. Okay. Now before going to this topic, I'll tell you, we have to resolve it. See, just you have to note one point very clearly. In this diagram, I have taken everything theta 1, theta 2, theta 3 and theta 4 with respect to the horizontal axis. Remember, always whatever may be the force acting in all the 4 quadrants, now we have taken the angle with respect to horizontal axis. That is very, very important. In some cases, the question may be asked, even the theta 1b may be asked with respect to the y-axis in first quadrant also, with respect to its y-axis. If it is taken that, then you have to find out the angle theta and bring it to the x-axis, because any one angle which is given with respect to y-axis and with respect to along with the x-axis, alternatively, you have to find out the angle with respect to all the angles with respect to vertical angles, or otherwise all the angles with respect to the horizontal angles. Now in this case, I have taken all the theta with all the forces angle thetas with respect to the x-axis. Okay. Now let us go to the problem. Let us see how to solve this question. Now if you see this in the first quadrant, I have taken along vertical, and because it is inclined at an angle, so any forces acting at an inclined force can be resolved vertically and horizontally. So I have taken this F1 in the vertical direction as well as horizontal direction. So since it is falling on the first quadrant, either y-axis will be a positive y-axis and x-axis also will be a positive x-axis. So that is why I have taken F1 cos theta 1 and F1 sin theta 1. So always remember, the vertical forces will be taken as sin theta as well as horizontal forces will be taken as cos theta, since the angle theta 1 is considered with respect towards the x-axis. Remember, the condition will be the vice versa if you are taking the angle with respect to y-axis. So that is also an important thing which you have to keep in mind, because some solution may be done with respect to the y-axis also. So both the things are correct, but in order to avoid some confusions, you have to consider the angles always with respect to the horizontal axis for all the angles, or otherwise you have to consider the thetas, the angles, all the angles with respect to y-axis with respect to the y-axis in order to avoid the confusion. Okay, fine. If we take the forces which is acting towards in second quadrant, I have just taken it as vertical as positive, that is positive F2 sin theta, and toward the horizontal axis towards the minus x direction. So I have taken it as minus f2 cos theta 2. I think you understood. You can understand this. The next one towards the third quadrant also, it's very clearly understood. That is, I have taken it as minus f3 cos theta 3 and minus f3 sin theta 3, because the third quadrant lies in between both minus and minus x-axis, negative x-axis and negative y-axis. Now similarly, I hope that if you take the fourth quadrant, one is we can take it as a negative y-axis and positive x-axis. So that will be shown now according to what you're seeing here. So here you can see it as f4 cos theta 4 as well as minus f4 sin theta 4. So now whenever all these forces are acting, you have to resolve this with respect to horizontal as well as vertical forces. And later, slowly, you have to take the summation of all the horizontal forces and the summation of all the vertical forces. And then you will get a sigma h as well as sigma v. So this is the way you have to proceed the problem. Okay, I hope you understood now, and directly we shall move to a problem. We shall take an example of a problem with the data, how to solve this one. Clear? Okay, fine. Now if you take this horizontally, so you can see here very easily f1 cos theta 1 minus f2 cos theta 2 and minus f3 cos theta 3 and plus f4 cos theta 4 is equal to 0. Now similarly, if you take the forces vertically, you will get it as the same value. So one thing, if you notice that if you are making all the angles with respect to the horizontal, all the sigma h values will become a cos values, and then all the sigma v values will be converted into sine values in order to avoid the confusion. Remember, once again I am telling, right? In the similar case, if you want to go further, if you take all this vertical force, all the angles with respect to the vertical lines, that is y-axis, the same vice versa will be taking place. That is, sigma h will become sine and sigma v will become cos. Okay, I hope you understood, and let us move to the next condition here. Okay, fine. Here, yes, now we can consider a particular problem to be solved here. Okay, now let us take some three coplanar concurrent forces are acting at a point as shown in the figure. So let us determine how the resultant and the magnitude of direction is found out. Now this is a diagram which is given as a question here. Now I hope, keeping all the ideas for the basic which I have taught to resolve the problem, the same similarly we have given some values with some values we have taken a question as an example. So in this question, let us consider a point O. At point O, away from that point O, some three forces or coplanar forces are acting at an, for example, it is taken as 200 Newton in first quadrant, 400 Newton in second quadrant, and 600 Newton in fourth quadrant. So when this type of forces is acting, you cannot define that exactly the system is at equilibrium. So your aim is to find out whether the system, at what force, if I am just giving a one more force, the resultant force, if I am finding out the resultant force, then it is very easy for us to resolve this and tell, okay, when I am just taking a resultant force towards this direction, then the entire system will be at equilibrium. So that is our aim now. Now how to solve it? As I told you, we have to resolve all the inclined forces horizontally as well as vertically. Now take this example here. First of all, if you take in your first quadrant, as similarly which I have given it as plus 200 sin 45 and plus 200 cos 45. Remember, always I have taken the angle with respect to horizontal axis, x axis. Okay. So in the second quadrant also similarly I can take it as plus 400 sin 30 as well as minus 400 cos 30. Okay. So I think you better understand. You can understand better. Like since I have told you once again in the previous topic also, previous PPT also, right? Slide also, right? Okay. Now in the third quadrant you don't have any force acting here. So similarly, if you go to the fourth quadrant, the forces are acting at an angle of 60 degree as 600 cos 60 as well as minus 600 sine 60. So that's all. So if you are able to resolve the forces like what you're seeing on the screen very clearly, and now it is very easy for you to solve a problem without doing any mistake. Now let us go for a sigma h. So if you just take the algebraic sum of horizontal forces, resolving forces horizontally, sigma h is equal to all values or cos values. You can just use your calculator and find out the value of 200 cos 45 and minus 400 cos 30 plus 600 cos 30. So all the values were given. So nothing is unknown. So directly we can find the solution and write the value of sigma h is equal to 95.01 Newton. Just you can take a calculator and then check it once again. Okay, fine. Similarly, if you do the same process for your sigma v also, that is resolving all the forces vertically, you will get an equation like what you're seeing on the screen as assigned values of 200, 400 and 600 with respect to its angle theta, theta 1, theta 2 and theta 3, right? So now by using your calculator, if you just find out the solution of this one also, you will get the answer as minus 178.2 Newton. Okay, fine. Now you have got the value of sigma h as 95.01 as well as sigma v as minus 178.2. So sigma h value is positive and sigma v value is negative. Now by having these two values, you can ultimately define that in which direction the resultant force is acting. So sigma h is positive and sigma v is negative. So very easily we can say that the force is acting at the fourth quadrant. Remember, the force will be acting at the fourth quadrant. Okay, fine. So you have found out the direction of in which direction it is acting. Right. And let us see the summation, how we are going to get the magnitude and resultant force. Okay, what value? So the direction you have found out in which quadrant the force is going to be acting. What force is going to act? So that is what you are going to find out now. So let us see, that is given, that can be done by the summation of sigma root of sigma h and sigma v. So it is given by the formula r is equal to root of sigma h squared plus sigma v squared. If you substitute these two values, sigma h and sigma v, in this equation, very easily we can get the value of force as here very easily as 201.95 Newton. So now the resultant force is 201.95. Hope you students is easy for you to understand now. Till now you don't have any doubts because it is a direct substitution and very simple. Since you are a beginner, you are going to learn very slowly, right? And then I hope you can understand easily. Now one more thing. So you have found out the resultant force and you know in which quadrant the resultant force is lying. Both the things you are able to find out. And next question, at what angle it has to act? That is very important. So you have to find out the value of angle theta. So this angle theta is given by theta is equal to tan inverse of sigma v by sigma h, right? You have the resultant force R, sigma h is given and sigma v you found out very easily. You know that it is lying on the fourth quadrant and you know you have to find out the value of alpha. That is your final output. That is your final output which you have to find out. So when you are finding your answer, the alpha, then almost your problem is completed. So the alpha is given by tan inverse of sigma v by sigma h. Using this formula, tan alpha is equal to sigma v by sigma h. You can write this value as alpha is equal to tan inverse of sigma v by sigma h, and your answer goes like this, as the value will be 61.93 degree. Now by this we can conclude that the resultant forces acting in the fourth quadrant, the resultant force also you have found out, and the angle, at what angle it is going to be acting in order to keep the entire forces at equilibrium. So if you are able to find out all this, then the solution is done. Okay. Now let us go to a similar problem like what you have done now. Let us take an example. The resultant force of system as shown in this is 5520 Newton along the negative direction on y-axis. Determine P and Q. So all these are given here. So now the question will be given here. So till the diagram will be given in your what is that? That will be given in your question itself. So a small change is there. So instead of giving an angle directly like what you have done in the previous problem, now here they are going to they are asking you to find out the angle theta 1, theta 2, theta 3, and then find out the resultant force P. That's all. So once in this problem, slowly I'm just going to a little bit next level of your question when compared to the previous one. Here, instead of giving the angle directly, they have given some value 3, 4, 3, 2, and then 5 and 12 accordingly, which you have to use your trigonometric method to find out the angle theta. That's all. So 3 by 4 represents, so for example, if you take your first quadrant, 3 by 4 represents the in the first quadrant. 3 by 4 represents the opposite by adjacent. So you know very well you can get the angle of theta. Theta is equal to tan inverse of 3 by 4. So that you will give that will be giving a value of theta 1 with respect to x-axis, and similarly theta 2 is equal to tan inverse of 3 by 2. That gives the angle with respect to its x-axis. Similarly, 12 by 5 will give with respect to its angle. So all the angle will be given by using your formula. Theta is equal to tan inverse of opposite by adjacent. That's all. Okay. So now let us see how to find out this one. So by this you will get certain values here. For example, if we find out the F1, theta 1 is equal to tan inverse of 3 by 4 angle is given as theta 1. Similarly, F2 is equal to P, you know very well. F3 is equal to theta 3, as I told you how to find out. Similarly, F4 also you have got the value as 56.31. So you are very clear that you have found out the value of theta 1, theta 3 and theta 4. That's all. Now by using these three values, you can find the remaining unknown values by using the resolution of forces either or otherwise, either by resolving the forces horizontally and vertically. That is what you are going to see. So now, you know, as the previous slides which you have done the similar problem, directly we can substitute the value, that is algebraic sum of horizontal forces, writing it as sigma h is equal to certain value which you are seeing on the screen now, and all these values are with respect to its horizontal forces, and similarly you will get a value of P cos theta is equal to 139.69. Right. Now here angle theta as well as P is unknown. Now we can go for sigma V. Resolving the vertical forces, very easily we can get one more equation here. Here also P sin theta will be an unknown value. So you will get the value as P sin theta is equal to 699.53, because all the other values are known very clearly. By using your calculator, we can find out the value of sin theta. Now if you just take these two equations, P cos theta and P sin theta, very easily we can find out, because by dividing either one by one equation over the other, cos by sine by cos, you will get the value of tan theta, and P will be cancelled, as well as we can find out the angle of theta as theta is equal to tan inverse of the value. So very easily we can see equation 2 by 1, and that gives, as I told you, sine by cos is equal to tan, P will be cancelled, and tan theta is equal to the value of 0.0057, and it gives a value of 78.7 degree. So this is the way you have to find out the value of theta. So you have found out the angle theta, and substitute this the theta value in equation 1 or 2. So by equation 1 or 2, if you are substituting, all the angle, the theta angle will be vanished, and one more unknown is nothing but the P. You can find out the P value very clearly as P cos theta is equal to 139.69, and theta is known here, so you can get the value as P is equal to 712.9 Newton, and theta is equal to 78.7. It's very, very simple when compared to the previous problem, and hope that every student are very clearly understanding about this resolution of forces by using these three formulas at the most. Thank you.